Welcome all. In this video, I'll be covering some practice questions on deflection of beams. This is the first video. I'll be making deflection of beams 1, deflection of beams 2, if required, deflection of beams 3. So this is deflection of beams 1. Okay, and I'll try my level best to include all varieties of questions under deflection of beams. Okay, chalo. Let's take, without wasting time, let us take the first question. Now, the deflection curve for a cantilever beam AB is shown. The deflection curve is shown, my dear students. This is given by some equation. Okay. Now, he is asking intensity of loading. The loading is parabolic in nature. The reaction at A and the reaction at support A. He is asked. So let us take this the equation, and he has given the deflection equation as, just take the equation, I'll write. So the deflection equation is given, just go through the deflection equation. I'll go through it. Chalo. Chalo. The deflection equation is given by, I'm writing this equation, sir. Whatever this equation is there, now let me write. So the equation is y is equal to q0 x square by 360 L square EI, okay, into 45 L power 4 minus 40 L cube x plus 15 L square x square minus x power 4. This is the equation given. The same equation which is given here, I'm writing on the next slide. Now, he is asking the intensity of loading, that is W. We know that from the deflection, from the theory of curvature of beams, EI d2y by dx square is equal to m. So here I am not taking the sign into consideration because he has not said whether the load is acting upwards or downwards on the beam. So no problem at all. So if the load is acting downwards, the deflection will be downwards. If the load is acting upwards, it will be upwards. So forget about downwards, upwards, forget the sign. Chalo. Now, what to do? You also know that dm by dx is equal to shear force V. Okay. And then dv by dx is equal to W. Of course, minus, I'm not taking that minus, it is rate of loading. Okay, sirs. So I'm just interested in magnitude, no problem at all. It means EI d2y by dx square is m. So if I differentiate this, I get dm by dx. But dm by dx is v. So now let us differentiate. Assume, and clearly you see, he has not said anything about the variation of X modulus. So E is constant. We assume it to be constant. And if you look at the beam, it is prismatic. As it is prismatic, the moment of inertia I is constant throughout. So he has not given any variation. So I is assumed to be constant. So therefore, I is constant, E is constant. Now you differentiate this. EI, now you differentiate this. d2y by dx square will be d3y by dx cube. And that is equal to dm by dx. Now you tell me what is dm by dx? It is V. It is V, that is shear force. Exactly. Now let us keep this equation because he's also asking the reaction. d3y by dx cube is equal to V. Now further let us differentiate this. So if I differentiate this, I get dv by dx. But dv by dx is W. He is asking the loading intensity only. Chalo. EI. Further, let us differentiate this. So d4y by dx power 4 is equal to dv by dx, and that is equal to the rate of loading W. So if you want the rate of loading W, I have to differentiate this deflection curve 4 times. First, second, third, fourth. Let us do that. Let us do that. So now I'll write EI d4y by dx power 4 is rate of loading. So he is asking the rate of loading, that is intensity of loading. EI d4y by dx power 4 is equal to, that is rate of loading. Now the equation of the deflection curve is given, and that is Q0 x square by 360 L square EI. Already this equation is given to us in the question. 45 L power 4 minus 40 L cube x minus plus 15 L square x square, okay, minus x power 4. Chalo, let us differentiate this. So dy by dx is equal to, if I differentiate, what do I get? This Q0 by 360 L square EI. Okay, sirs. Now what we do is, let us take L square inside. Let us take L square inside. So this will be 45 L power 4. Listen, now you are differentiating. So this is inside. So what is the differentiation of x square? Directly add it 2x. Wonderful, sirs. Wonderful. I repeat, sirs. You have not understood. My x square andar le lunga. If I take inside and differentiate, x square will be 2x minus 40 L cube. You take x square inside. Already there is x into x square is x cube. Differentiation of x cube is 3x square plus 15 L square. L is constant. X square into x square is x power 4. Differentiate. Here x square into x square is x power 4. What is the differentiation of x power 4? 4x cube minus x square into x power 4 is x power 6. So therefore x power 6. So therefore x power 6 is 6x power 5. Excellent, sirs. Excellent, no problem at all. Now further you differentiate. Further d2y by dx square differentiate karo. So Q0 by 360 L square EI is into, if you differentiate this, you'll get 45 L power 4 into 2, differentiation of x is 1, minus 40 L cube and into 3, x square is 2x plus 15 L square into 4, x cube differentiation is 3x square minus 6 5 is 13. So x5 is x power 4. Okay, sir. And let us differentiate further. So what I do is, let me erase this. Let me erase this, my dear students. Isko main hata dunga, sir. So let me erase this. In the same slide, let's try to do this. Now, further let us differentiate. So d3y by dx cube is equal to, you further differentiate this. So what do I get? Now if I differentiate this, Q0 by 360 L square EI into, so this is pure constant, L is constant, so 0 minus, यहाँ पे 3 into 2 is 6, 40 into 6 is 240 L cube, 240 L cube, and differentiation of x is 1 plus 4 into 3 is 12, so 15 into 12, okay, this 4 into 3 is 12, 15 into 12, L square, differentiation of x square is 2x, wonderful, sir, minus, and 13, what is x power 4? It is 4x cube, excellent. So last time, let us differentiate for the last time, my dear Mitro, let us differentiate this for the last time. Chalo. D power 4 y by dx power 4 is equal to Q0 by 360 L square EI into, and this is constant, differentiation of constant is 0. ठीक है sir. So therefore ये तो 0 होगा, ये भी 0 होगा, so this will be 15 into 12 L square and into 2, differentiation of x is 1 minus 30 into 4 is 120. 30 into 4 is 120. X cube is 3x square. Excellent, sirs. So let me erase. ये भी चाहिए. Very good, sirs. Now don't worry, sirs. आराम से पढ़ लेना. Let us not waste our time. चलो. Now let's take this. So d4y by dx power 4 is equal to Q0 by 360 L square EI into ये होगा 15 into कितना होगा सर 15 into 24 L square minus ये होगा 316 into x square. Excellent sir. What is 24 into 15? एक बार देखते हैं सर. 24 into 15 is 3. This is 360. This is 360. Let us take it out. So d power 4y by dx power 4 is equal to this 360, this 360, this 360 gets cancelled. So you are left with q naught by L square EI ठीक है into L square. Already this 360 is gone, 360 gone, minus x square. So we know very clearly. Let us take EI onto the left side. So if I take EI onto the left side, it will be EI d power 4y by dx square is equal to EI, you take this to this side, d power 4 is equal to q naught by L square, q naught by L square, q naught by L square into L square minus x square. But everyone knows EI d power 4y by dx power 4, EI d power 4 by dx power 4, एक बार check कर लेना. EI d power 4 by dx power 4 is W. So therefore, this is our rate of loading. So W is equal to Q naught by L square into L square minus x square. This is the rate of loading. Hope this is clear. एक बार check करते हैं sir. Let us check the option. Let us check the option. Yeah. The intensity Q naught by L square. So option A is correct. And moreover, what type of loading is this? So rate of loading is square. It is parabolic in nature. Definitely, it is parabolic in nature. तो ये भी सही है सर. तो ये equation parabolic है सर. This is a parabola equation. So it is parabolic in nature. Now he is asking what is the reaction at the support A. How to find out reaction at the support A? एक बार देखना सर. Just देखना. Reaction at the support is nothing but it is the shear force. It is the shear force. If you want the reaction at the support, if you want the reaction at this support, it is the shear force. तो कुछ नहीं है सर. EI, where is that? EI d3y by dx square is the shear force. Let us calculate. But where do you want? ध्यान से सुनो. Where do you want, my dear students? बोलो कहाँ से चाहिए? कहाँ चाहिए? यहाँ पे. इसका मतलब he has given this is the y-axis and this is the x-axis. So this is the origin. So he is asking reaction at A. Reaction at A means x is equal to 0. Reaction at A means x is equal to 0. देखो एक बार. So EI d3y by dx cube is a shear force. Shear force is nothing but the transverse loading. He is asking reaction. If this is the beam, यहाँ का reaction पूछा है सर. यहाँ का reaction. It may be upwards, it may be downwards. How sir? If the loading is downwards, the support will be upwards. Reaction will be upward. If the loading is upward, it will be downward. Forget about the sign. So he is asking the shear force. मतलब आपको यहाँ का shear force चाहिए. Where do you want shear force? At x is equal to 0. But what is the equation of shear force? EI d3y by dx cube. Already you know d3y by dx cube. Let me check. Already you know d3y by dx cube. So एक काम करते हैं sir. Let me erase this because already we have obtained the rate of loading ना ये गया. चलो. Now तो एक सेकंड. तो EI and d3y by dx cube is equal to V. He is asking shear force where at x is equal to 0. That is the reaction because at the left end, at the fixed end, he is asking the support reaction. Means he is asking shear force at x is equal to 0 because this is the beam and यहाँ पे reaction पूछ रहा है. तो this is my x axis, x and this is my y axis. तो x is equal to 0. d3 by day. Put x is equal to 0. जब यहाँ पे तो कोई x ही नहीं है सर. यहाँ पे कोई देखो EI ठीक है into d3y by dx square. So EI into d3y by dx square. d3y by dx square. Q naught by 360 L square EI correct into put x is equal to 0. x0 तो ये 0 हो जाएगा. x0 ये हो जाएगा. ये already 0 है. You will get this minus 240 L cube. ठीक है सर. Now क्या करेंगे? This EI gone. Let us take only magnitude. तो क्या बचेगा सर? This 0 is gone. There is L square. L square मतलब L cube है L है. So this will be there is 24 Q naught L 24 Q naught L by 36. So 12 2 is 12 3. So it is 2𝑄0L by 3. That is the support reaction at x is equal to 0. 2𝑄0L by 3. 2𝑄0L by 3. Option D is correct. It's not L square, it is L. So beautiful question, sir. एक बार मैं check कर लूँगा, sir. मेरे प्यारे दोस्तों, let me check. Wonderful students of India. So hope you got this. 2𝑄0L by 3. A, B, D options are correct. So actually in one question we have done so many other questions. So hope this is clear. Now let's go to the next question. Without wasting time, let us go to the next question. Please read this question. I request everyone to read the question. Hope it is clear. Hope it is visible. Hope it is visible. Come on, come on. Come on. Come on. देखो. For the beam given below, मतलब ये वाला, the point of contraflexure from end B, from this one, please listen carefully. It is a propped cantilever. There is a cantilever beam. At L by 2, there is a downward point load of P. And at L by 2, and from this way, there is a support reaction. So, क्या पूछ रहा है sir? He is asking, what is the position of contraflexure from the end B? इस end से where is point of contraflexure? You know that point of contraflexure is that point where the bending moment is 0, where it changes its sign. That is, the bending moment is 0 at the point of contraflexure. Chalo. The first thing that we need to note in this problem is we have to calculate the support reaction. Once the support reaction is known, I can easily write the bending moment equation and equate it to 0, and I can find the position where the bending moment is 0. Chalo, let us take this beam and take a new slide. Chaliye sir. This is the cantilever, ठीक है, but there is a point load of P. Yes, can you see? Yes, and this length is L upon 2. ठीक है sir. And here there is a support reaction. Very good. Now, let the support reaction be B. तो ऐसा करेंगे हम. Let me erase this. ठीक है sir. So there is a support reaction. Let me write it as RB. First, let us calculate the support reaction. How do I calculate the support reaction? And if you see the figure of this, and definitely it is propped at end B. So at this point, the deflection should be 0 because there is a support. Otherwise, if you remove this support, there will be deflection, sir. There will be deflection. But as you have kept a support here, the deflection is 0 at this point. So कैसे करेंगे sir? This point B, and let us say this is point A. This point B is under the influence of two loads. One is due to this P, the other is due to this P, RB. चलो, पहले हम क्या करेंगे? Let us take case 1. And you know, this is point B, this is your load P, this is end A, and this is our L by 2, and this is also our L by 2. Excellent, sir. My dear students, under the influence of this load, let me find out the deflection here. Case 1. Next, under the influence of this load, RB, this is B and this is A, and this total length is L. Okay, sir. Under the influence of this load, let us find out the load. Sorry, deflection. So, because of this, there is a deflection upwards. Because of this, there is a deflection downwards. But there is a support here. The net deflection at this point must be 0. So, what I do is, let me calculate the deflection due to this downward load P at this point. Then, I'll calculate downward. Then I'll calculate this upward deflection due to this. Both should be same. The magnitude of both should be same. Then only the net downward deflection due to the load P, the upward deflection due to load P should be 0. Why it should be 0? Because there is a support at end P. And we know very well, what is the deflection here? It will be, you know, whenever there is a cantilever beam and you have a load at the free end, point load at the free end, it will be PL cube by 3EI. So here in place of P it is RB. So therefore it is RB, the length is L by 3EI. Excellent, sirs. Excellent. And let us find out the deflection due to this. And it is in what direction? It is in the upward direction. Now, we know, my dear students, let us find out the deflection here. Here, it will be PLQ by 3A. So actually, if you see, let me show you very clearly. If you see the deflection curve, there is no bending moment in this. Here, the deflections are due to bending. So therefore, if you see the elastic curve, it will be something like with zero slope here and something like this. And then there is no load here, therefore it will be a straight line. So I want the deflection here. So I will calculate this deflection, and what I do is, you know the slope, let this point be some C. I'll find out the slope at C. If you want the deflection here, let me write this as y2 and let me write this as y1. And we know clearly y1 can be, this is y1, sirs. y1 can be calculated very easily. How? So y1 is equal to cantilever with a point load. If we take only this as the cantilever, it will be PL cube. But L is L by 2. PL cube by 3EI. Excellent, sirs. And we know that for a cantilever beam with a point load, if you want the slope here, already we have derived. I have derived in my regular classes. अगर यहाँ पे अगर free end पे slope चाहिए due to point load, it is PL square by 2EI. So यहाँ पे, if you want the slope at C, at this point, it will be PL. But what is L? This is L. This is L. This is L. PL square by 2EI. This is the slope. And you know, tan theta is slope, tan theta is opposite by adjacent. So, अगर आपको ये चाहिए, so tan theta, this is the slope. Slope is equal to tan theta is slope. ये तो slope है sir. ये तो slope है. Slope is equal to tan theta, which is y2 by this length, and this length is also L by 2. So therefore, slope is equal to, ये slope अगर चाहिए, it will be y2 by and L by 2. So if you want y2, it will be theta c into L by 2. Already theta c is known. So y2 can be written as, अगर आपको y2 चाहिए theta c, it is p L square by 2 into 2 is 4, 4 into 2 is 8 EI. So okay, ये theta c होगा. This is theta c, this is theta c into L by 2. So into L by 2, so this will be y2. So if you want the total deflection at B, it will be y1 plus y2. So what is y1 plus y2? Let me erase this, sir. थोड़ा क्योंकि ना, let me erase. Let me erase this. Do not worry, my dear Mitro. So deflection at B is equal to y1 plus y2. What is y1? What is y1, Mitro? y1 p L cube. This is L cube. 2 cube is 8. 8 3 is 24. And 2 cube is 8. 3 is 24. This is 24 EI plus y2. What is y2? What is y2? PL cube by L square into L 8 to 16 EI. And this is the deflection, and this total deflection is downwards. इसका total deflection is downward, but there is a support at B. इसलिए ये downward and upward should be same. So equate these two. ये कितना आ रहा है sir? I think PL cube by क्या common ले लेंगे रे बाबा? इसको मैं ऐसा करता हूँ sir. I will take 8 common, 8 EI. I will take 8 common. 8 common ले लूँगा. So it will be 1 by 3 plus 1 by 2. So it is 2 plus 3 is 5 by 6. So it will be ये पूरा आएगा 5 PL cube. अरे यार 2 plus 3 is 5 by 6. 6 into 8 is 48 EI. Very good, sir. This is the deflection due to P, and this is the deflection due to RP. Equate both. If I equate both, 5 PL cube by 48 EI is equal to RBL cube by 3 EI. So EI is gone, L cube is gone, and 3 ones 3 16s, 3 ones 3 16. So RB is equal to 5P by 16. Excellent, sir. So we have calculated the support reaction. ठीक है. So now let us draw the figure. This is our P. This is L by 2. Again, this is L by 2. This is point B, and the support reaction is upwards. And how much is this, sir? This support reaction is 5P by 16. एक बार check करेंगे सही है गलत है? 5P by 16. Excellent, sir. 5P by 16. अब देखो sir. From the end, he is asking where is the bending moment 0. I am sure that. ध्यान से सुनो. So here there is only one sense of movement which is anti-clockwise. तो यहाँ से when x is in, of course यहाँ पे 0 है वो छोड़ दो. यहाँ पे तो bending moment cannot be 0 0 0. But इस position में B से अगर कहीं आप ये position लिए, if you take some position, my dear students, if you take some position, let us assume this to be x. So definitely possibility is there. क्यों? Because ये anti-clockwise है और ये clockwise है. There is a possibility both can become same. Let this distance be x. So let us calculate the bending moment here. So what will be the bending moment here, sir? It will be 5P by 16 into x. This is anti-clockwise and this is clockwise. So what is that? P into ये वाला distance. देखो यहाँ पे bending moment ले रहा हूँ. I am taking at this section, at this section, at this section. So RB into x, RB into x, and minus ये anti-clockwise है, ये clockwise है. Minus P into what is this distance? X minus L by 2. If you want this to be point of quantum flexure, at the point of quantum flexure, the bending moment changes its sign. So therefore, यहाँ पे bending moment will be 0. So I have calculated bending moment at any section XX. And for the, if you want this point to be the point of quantum flexure, here the bending moment must be 0. Excellent, sirs. So 5px by 16 is equal to p. You take it to that side. L by 2. Excellent, sirs. What is x minus L by 2? ये x है, ये L by 2. This moment, this will be p into x minus L by 2, and this will be x. ठीक है. ये गया. So 5x is equal to 5 into x is 16 into x minus L by 2. 16 into x minus. Okay. So 5x is equal to 16x minus 8l. Where from you got 8? 16 2, 16 2, 16 2, 16 by 2. Okay. Now 8l is equal to 16x minus 5x. So 8l will be equal to 11x. So if you want x, it will be 8l by 11. So at this point, the bending moment is 0. If you calculate 8 by 11, you are getting 0.727. 0.727. X is equal to 0.727 L. Where is that? X is equal to 0.727. So this is the right answer. Again, a good question. Shall we proceed? बहुत बढ़िया. बहुत बढ़िया. Next. Let's go to the next question. Take this question. Write this question. The cantilever beam AB has an extension BCD. Actually, this is the cantilever. It has an extension of BCD. ठीक है. Attach it to its free end. मतलब इस free end पे एक extension is attached. So to this free end, extension is attached. A force P acts at the end of extension. At the end of extension, a force P is acting at the end of extension as shown. What is he asking? The ratio, this distance is given as A and this distance is given as L. He is asking what should be the ratio A to L, so that the deflection at this point is 0. So to obtain deflection at this point as 0, so if you want the deflection here to be 0, what should be the ratio A to L? The second question is, what should be the ratio A to L, so that the angle of rotation? What does angle of rotation mean? Slope. So if you want this slope, there are two questions. It is MSQ, sir. This is MSQ. If you want this slope at point B, to be 0. What is that? So two things he has asked in this question. One is, what should be A by L if you want the deflection at point B as 0? Next, if you want the slope at point B to be 0, what should be the ratio A by L? And this A is given as L, this is given as A. तो चलो अब हम इसको करेंगे सर. Not that tough, but a good question. चलो कलर थोड़ा चेंज करेंगे क्या? आपकी मर्जी सर. दिख रहा है क्या रे? ठीक नहीं दिख रहा है. कलर कॉम्बिनेशन सही नहीं है रे बाबा. नॉट गुड. तो मैं कुछ कोशिश करूंगा. कोशिश करते हैं सर. There is a load P and this length is given as L and this is given as A. ठीक है. कोई बात नहीं. Now what I do is I'll do something. He is focusing everything at this point. तो एक काम करते हैं सर. We'll do one thing. What we do is, my dear students, what I do is, let me introduce a load like this. A load like this. A simple concept of mechanics. So whenever I substitute two loads equal in magnitude but opposite in direction, it has no effect. Please, why? They are not separated by any distance, so there is no net couple, and they are equal and opposite. Net force is also 0, so I can do like this. Now, if you see, my dear students, if you see this combination, this P and this P, this is down, this is up, so therefore it is creating anti-clockwise moment of magnitude P into A. P, this is P and this is A, P into A. So if I replace this and show by this diagram, it will be something like this, my dear students. I will take only this portion AB, no problem at all. So please look at this load P is there. उसका कोई ये नीचे वाला load, I'm talking about this. It is there. Okay, कोई बात नहीं sir. And these two are creating an anti-clockwise moment. So therefore it is anti-clockwise. Of what magnitude? This is P and this is A, anti-clockwise. So this is PA. So this point B is under the influence of two loads. Don't think that load means just force. Moment is also a load. Torque is also a load. So force is also a load. So there is an anti-clockwise moment and there is a point load at B. This anti-clockwise moment will try to lift it up. It tries to deflect this in upward direction. And this downward force will try to deflect in downward direction. So he is asking, what, and this length is L. Okay. Now, what should be this ratio so that the deflection at this point B is 0? Very good, sir. We have studied in our deflection of beams. Now, let us take only this point. देखो P load. देखो ये तो downward है sir, downward at point B. Okay, this is A. Now this is B. So second case is there is a moment of PA and this length is L. This length is also L. Now, what will be the deflection due to this downward? It will be PL cube by 3EI because, and this will be because of this point load P at the free end, it is PL cube by 3A. And you tell me, due to this moment, what will be the deflection? ML square by 2EI. I think I have derived. These are the most standard results that you need to remember. So M is PA, M L square, ML square, L square by 2EI. So because of the concentrated moment for a cantilever, the deflection is given by ML square by 2EI. M is PA. These standard results you are supposed to remember. This is also a standard result you are supposed to remember. And this deflection, it will try to lift it up. And it will try to deflect it downwards. So this is in the upward direction. And he says, when is the deflection at this point 0? When the upward downward is same, the net effect will be 0. Equate these two. So therefore, Now I get PL cube by 3EI is equal to PAL square by 2EI. So this EI is gone. So P is gone. और कुछ sir? L square L is gone. So we are left with A by L is equal to A by L is 2 by 3, I think. A by L is 2 by 3. Let me check. A by L is 2 by 3, I think. Very good, sir. When the deflection is 0, A by L is, where is that? The ratio A by L to 0 is 2 by 3. I think option B is correct. I think option B is correct. Am I right? Bilkul, sir. And now we'll go to the second case. He is asking when is the slope 0? एक बार देखना sir. Again I will take the same thing. There is a downward force P. There is a moment of PA and this length is L. ठीक है sir. Now observe here. सुनो sir. Look at what is the slope due to this point load at the free end. He is asking slope here to be 0. What is the slope? If the length is L, the standard result is the slope at B is PL square by 2EI due to point load. And similarly, if you take this, there is a moment of concentrated moment of PA. This length is L. So this is the moment. What will be the slope at point B, sir, due to moment? The slope at this point due to moment is ML by EI. These standard results you are supposed to remember. I repeat, these standard results you are supposed to remember. So therefore, now slope at B is M is PA, L by EI. तो when एक तो upward है, एक तो downward है. Hope you understood. One is this slope, one is this slope. One is negative slope, one is positive slope. So when can the slope at point B be 0? When both are of same magnitude. To equate this slope to this slope. So therefore, PL square by 2EI must be equal to PAL by EI. So EI is gone, P is gone, L is gone. So A by L is equal to कितना आ रहा है सर? 1 by 2. I think A by L is 1 by 2. So let us see the option. A by L, when the rotation का मतलब slope is 0, it will be 1 by 2. So options B and C are correct. Now let us go to the next question without wasting time. चलिए मेरे प्यारे दोस्तों, चलो let us take the next question. ये वाला पढ़ो. Very good students. Don't waste time. फटाफट. Let's not waste time. Please read the question. मेरे प्यारे दोस्तों,
मेरे प्यारे दोस्तों, मेरे प्यारे दोस्तों, मेरे प्यारे मित्रों, मेरे प्यारे दोस्तों, दोस्तों 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 दोस्तों, मित्रों मित्रों.
come on, read the question. पढ़ो.
पढ़ के पागल बनेंगे रे, नकल मार के नवाब बनेंगे रे,
है ना? चलिए चलो. Let's read this and try to do this. For the beam and loading shown, determine the spring constant K for which the force in spring is equal to 1/3 of the total load on the beam. क्या पूछा है सर? He is asking spring constant. अच्छा सवाल है सर. It's a good question. For the beam and loading shown, मतलब ये दिया है. Actually, what is the given? There is a simply supported beam with a uniformly distributed load of W. And at the midspan, at the middle center of the beam, there is a spring supported whose spring constant is K. But clearly he gave in the problem, the spring force is 1/3 of the total load. एक बार देखेंगे सर. What is the total load? The load is W per unit length. The load is W per unit length. What is the total length? It is L plus L. L plus L, it is 2L. So what is the load? Load is equal to per unit length. For 1 meter length, it is W. For 2L, it will be W into 2L. So the total load is equal to 2WL. Excellent, sir. Then what is the spring force, sir? The spring force is given by, he has given, the force in the spring is 1/3 of the total load. 1/3 of the total load is 2WL. So the spring force is given by 2WL by 3. ठीक है सर. अब इसको सॉल्व करते हैं सर हम. Now let's try to solve this question. Now there is a support here. It is a simply supported beam. There is a support here. Let me write it as RA. Let me write it as RB. और ये सेंटर है सर. ठीक है. And there is a UDL. ठीक है. Now please understand carefully. बहुत सिंपल है सर. बहुत सिंपल है. तो due to this load, बहुत carefully देखो. बहुत carefully देखो. Due to this load, now I am drawing the free body diagram, sir. Now due to this load, क्या पूछा है सर प्रॉब्लम में? If the spring force is 2/3 of the total load, what should be the spring constant K? So we are supposed to find out the spring constant K. अब देखो, because of this load or per meter length or per unit length, this will deflect down. So this load and the beam will try to move down, thereby compressing the spring. तो स्प्रिंग को कंप्रेस करेगा. जब स्प्रिंग को कंप्रेस करेगा, क्या स्प्रिंग चुप बैठेगा? स्प्रिंग विल exert a force. So therefore here we have a spring force. So there is a downward deflection due to UDL and there is an upward deflection due to spring force. So what will be the net? तो ध्यान से सुनो सर. When the load is acting in downward direction, the beam will try to come down. When the beam tries to come down, it will try to compress the spring. But spring will oppose and it will exert a force in upward direction on the beam. So the beam is under the influence of UDL and spring force. So because of this, there is a net deflection. So let us calculate the net deflection of the beam. And you know very well, whatever the beam is deflecting by net amount, the same is the deflection of spring. क्योंकि दोनों connected है sir. Both are connected. So whatever the net this beam is, so due to this it is moving down. Due to this it is moving up. So दोनों के influence में there is a net deflection. So whatever the net it is deflecting, that will be the net deflection of spring. जितना beam due to UDL it is deflecting. Due to UDL it is deflecting. Due to spring it is deflecting. Net downward should be equal to whatever net it is, whatever due to the net of force it is moving, or whatever the net deflection is taking place under the influence of these two, that will be the deflection of the spring. So I will calculate the deflection, net deflection of the beam. That will also be the deflection of the spring. Let me repeat. Confuse मत होना. तो आप बताइए सर, what will be the deflection of the spring? Force. अरे यार, आप बताइए, what is spring index? Force per deflection of the spring. So deflection is Fs by K. So whatever the spring is deflecting, it is because of the net deflection of the beam. So I will calculate net deflection of beam and that should be equal to the net deflection of spring, which is Fs by K. तो पहले हम क्या कैलकुलेट करेंगे? इधर देखो सर. Let me repeat, confuse मत होना. UDL downwards, spring force upwards. तो upward downward, net दोनों के influence में net नीचे आएगा. That net नीचे is nothing but the deflection of the spring. तो deflection of spring is given by Fs by K. तो beam का net deflection calculate करेंगे. That is the net deflection of the beam, which is also equal to net deflection of spring, which is Fs by K. चलो ठीक है सर. Now मित्रों आराम से आ जाइए. Don't worry. तो एक काम करता हूँ सर. This is 1 second है. Second है. This is 1. चलो. What is this length L ना? एक बार देखो लेंथ कितना है. L plus L 2L. Be careful, sir. Be careful. यही तो mistake हो सकता है. It is 2L. The total length is 2L. Let me recheck. L plus this is L, this is L. Correct. Right. अब देखो. I think you have studied. I think अरे ये तो गलत हो गया सर. ऐसा कैसा होता है? तो सपोर्ट तो ऐसा होना चाहिए. So because ये upward है, पागल हो गए हम भी. हमरे पागल, तुमरे पागल. ठीक है. अब देखो. देखो सर. Now observe here. What will be the deflection? Because the spring is at the center. What will be the deflection? I think हम पढ़े थे. 5 pi 384 W L power 4 by EI. L. What is L? 2L power 4 by EI. And this will be in the downward direction. ठीक है. And whatever this, whenever there is a simply supported beam with a point load at the center, it will be WL by 48 EI. W के place में FS है. WL, what is L? 2L. WL by 48 EI. ये किस डायरेक्शन में होगा मित्रों? ये किस डायरेक्शन में होगा? ये अपवर्ड होगा, ये डाउनवर्ड होगा. नेट डाउनवर्ड देखेंगे तो this minus this, नेट डाउनवर्ड is this minus this. तो that will be the net deflection of beam. So therefore, net deflection of beam because of load ये तो डाउनवर्ड ही जाएगा ना. मैं साइन नहीं लिख रहा हूं. Because of the load, अरे यार देखो ये लोड के कारण ये तो डाउन ही जाएगा. मैं डाउनवर्ड कैलकुलेट कर रहा हूं. So it will be this minus this. So it will be 5W मित्रों 2 power 4 16 2 2 4 4 4 16 into 16L power 4 by 384 EI minus एक upward downward एक upward. So it is 2 2 4 2 8 2 cube is 8 FS L cube by 8 FS L cube by 48 EI. Excellent sir. कुछ कर सकते सर हम? Can we do something? We'll plan. We'll see. And that should be equal to the net deflection, whatever it is deflecting. And that should be, net deflection should be equal to deflection of spring. And this should be equal to deflection of spring. Because whatever the beam is deflecting, and deflection of spring is given by Fs by K. Deflection of spring is given by delta is equal to Fs by K. So this should be equal to Fs by K. So क्या करेंगे सर? एक काम करते हैं सर, इसको इरेज करेंगे सर. Don't worry sir, don't worry. Let me erase this. बहुत बढ़िया. हाँ, तो 6 कुछ कैंसल हो सकता सर? I think there is a possibility. 5W 16 ones 16 twos 32 4. तो 5W L power 4 by 24 EI minus 8 L. अरे यार इसको भी कैंसिल कर सकते. 8 ones 8 6 8 6 8 ones 8 6. तो FS L cube इसको मैं इरेज करूंगा सर. देखो L cube by 8 E, sorry, it is 6 EI. 6 EI, but FS is also left. FS L cube by 6 EI. So there is FS left, but FS is already known to me. What is the value of FS, sir? FS is equal to 2WL by 3. FS is 2WL by 3. And that should be equal to, this should be equal to, this net deflection is FS by K. FS is 2WL by 3 by K. Simplify करेंगे sir. So we'll simplify. 5WL power 4 by 24 EI minus 2 ones 2 threes WL power 4 by 9 EI. How 9? 3 into 3 is equal to 2WL by 3K. Excellent sir. कुछ कैंसिल कर सकते सर. I think WL can be removed. तो WL तो यहाँ पे L cube बचा है. WL तो यहाँ पे L cube बचा है. WL is gone. I think 3 ones, 3 threes, 3 8s. So therefore 5 L cube by 8 EI minus L cube by 3EI is equal to 2 by K. Excellent. So further we can simplify. कितना रहा है सर ये? 5 3 is 15, 8 3 is 24. So denominator is 24 EI left side. I'm talking about left side. 8 3 is 24 EI. 15 minus 5 3 is 15 minus 8 L cube. Excellent. 5 3 is 15 minus 8 EI is 2 by K. ठीक है. So K will be equal to, if you want K, it will be 24 into 2 is 48 EI by 15 minus 8 is 7 L cube. So the spring constant is 48 EI by 7 L cube. कहाँ है रे? 48 EI by 7 L cube. I think option C is the right answer. Let me check. Option C is the right answer. Hope you understood, मेरे प्यारे दोस्तों. Let's take the next question. ये वाला लीजिए. Come on, take this. This is at x is equal to 0. Come on. A cantilever beam, when viewed from the top, has a triangular configuration. The thickness of the beam is constant, as shown in the side view. This is the one. So, okay, it has a, क्या बोला है sir? Now the moment of inertia is changing. अच्छा, it's not of constant cross section. ठीक है. So only the depth is same, but I mean the thickness of the depth is same, but the width is varying. So at the fixed end the width is b, at the free end the width is 0. ठीक है sir. Now I have a question. मित्रों, अब देखो. Dear students, let me calculate. So actually, if you visualize, पूछा क्या है sir? What is he asking? The deflection due to the load P at the tip. मतलब यहाँ पे he is asking deflection. बहुत बढ़िया. Whenever you have a change in moment of inertia I, you can go for moment area method. Moment area method. ठीक है sir. Now let's try to do this. So if you see, it's like this, sir. Everywhere the depth is same, but the width is not same. एक काम करेंगे sir. Let us calculate. So very simple, sir. यहाँ पे हम ऐसा करेंगे sir. Let the width here be bx. So let me take this as x, where x is taken from the free end. यहाँ पे. ठीक है सर. Okay, no problem at all. Hope you understood. Actually, उसका shape ऐसा है, triangular section, but the depth is same, only width is changing. Hope you understood. So it is like this, and the depth is same. So width is changing. So here the width is 0, increasing, and at the fixed end it is b. So from similar triangles I can calculate. So you know from similar triangles, bx by x is equal to. Please note down, it is not b into x, b suffix x. Bx, this length by this length is equal to this length by this length. So it will be b by L. I repeat, my dear students. So this length by this length is equal to this length by this length. So similar triangles. So if you want width at any section x from the free end, it will be b into x by L. If you put x 0, b will be 0. Yes. If you put x is equal to L, x is equal to L, L by L is going to be correct, matching. Now, कोई भी section ले लेना sir. You take any section, my dear students. You take any section. So if you see that section, of course it is a rectangular section, sir. कोई भी cross section cut करके देखना, it will be something like this. What is the depth given, sir? H दिया है, sir. Very good. And you know the width, this width is px. समझ में आ रहा है? अगर आप एक व्यू लिए कट करो, कोई भी सेक्शन कैसे बता रहे आपको, it's like this, it's like this, it's like this. ये यहाँ पे थिकनेस टी है, ऐसा है. तो कट करके देखना, आपको रेक्टेंगुलर सेक्शन आएगा, विड्थ b आएगा, डेप्थ h आएगा. तो विड्थ b at a distance x, at a distance x is ये दिया है. Very good, sir. Now observe here. तो मुझे बताइए, what is the moment of inertia? It is b d cube. D के प्लेस में h है सर, bd cube by 12. It is the moment of inertia at any section x. Very good sir. बहुत बढ़िया. इतना सिंपल क्वेश्चन है सर ये. आप ना you may be confused sir, ऐसा टफ लग रहा है ना. So we'll do one thing. The problem, let us take, there is a point load P. There is a point load P at the free end. So यहाँ पे P है. So what will be the moment at any section x sir? It is P into x. This distance is x. Let us calculate P into x है ये. Let us calculate m by ei. क्योंकि मैं क्लास में बताया था, whenever you have a variable moment of inertia, go for moment area method. M by ei. तो m क्या है सर? किसी सेक्शन पे m क्या है? P into x by e. E तो कांस्टेंट है सर. Now I, what is I? It is bx h cube by 12. So therefore m by ei is equal to, this 12 will sit at the top, p into x by e b suffix x h cube. But already b suffix x is known. What is b suffix x sir? B into x by l. Already it is known. Put it here. So if you want m by ei, it will be 12px by e into bx. What is bx? B into x by l. That l I'll take to the top. That l. bx ka value. I'll b into x by l into h cube. We are very fortunate x gaya. So m by ei will be equal to, so 12l by EB h cube. What is your conclusion? 12 EAX cancel होगा. 12P, P भी है सर, माफ करना. 12PL by EB h cube. Excellent sir. Now you tell me, my load P is constant, length is constant, E is constant, width B value at the fixed B constant है, या BX नहीं है sir, it is independent of X. So my m by ei is same everywhere. So my m by ei is same everywhere. So therefore, my dear students, इधर देखो, my m by ei is same, which is 12pl by ebh cube. 12pl by ebh cube. Let me write 12pl by ebh cube. Very good. तो अगर हम ड्रॉ करेंगे मित्रों m by ei, this length is l and this is m by ei. What is the value of m by ei sir? What is the value of m by ei? M by ei is 12pl by ebh cube. मैं क्लास में बताया था. तो इसका सेंट्रॉइड कहाँ पे होगा? यहाँ पे होगा. And what is this distance at l by 2? And if you want the deflection, moment of the area of m by ei diagram, moment of the area of m by ei, कितना clearly tangential deviation of a with respect to b. मैं बहुत डिटेल में पढ़ा है सर. What is the physical meaning of tangential deviation of a with respect to b? तो कुछ नहीं है. तो इस एरिया का what is the area? 12pl by ebh cube is this length, width is l. इस एरिया का मोमेंट लेना. So CG कहाँ है इस एरिया का? L by 2. So therefore into L by 2. This will be equal to 12. ये तो 6 हो जाएगा सर. So it will be, ये तो ऑलरेडी मैं क्लास में बताया सर. Why to take area of the moment of this m by ei diagram? क्यों लेना चाहिए? क्लास में कितना साफ बताया था. इधर देखो सर. तो अगर यहाँ पे देखेंगे, what is the tangential deviation a with respect to b? मतलब ये क्या दे रहा है सर? This tangential deviation is giving what deflection. इसलिए मैं आपको मोमेंट लिया. ये सारे मैं क्लास में बताया था सर. So therefore 12, this is 6pl cube by ebh cube. So 6pl cube by ebh cube. एक बार देखेंगे सर. 6pl cube by ebh cube. See, I think 6 negative sign shows downward deflection. एक बार चेक करते हैं सर. The negative sign shows downward deflection. मस्त क्वेश्चन था सर ये. दिस इज अ गुड क्वेश्चन मेरे प्यारे दोस्तों, दिस इज अ गुड क्वेश्चन। एक बार और दूसरा सेट में थोड़े टफ क्वेश्चंस रहेंगे सर। इन द सेकंड सेट वी आर गोइंग टू हैव सम टफ क्वेश्चन। कौन सा क्वेश्चन है रे मेरे प्यारे दोस्तों? मेरे 6pl³ by EBH³। यस एग्जैक्टली 6pl³ by EBH³। 6pl³ by EBH³। Thank you, my dear students. This is the first part of deflection of beams. Second part is coming. थोड़े tough questions रहेंगे सर. Okay. Thank you, my dear students. Bye bye.